All right, so we're going to look at this sum up here, x to the n over 2n squared, and we're going to start every time with these because they're called power series because it's x to a power. Every time we're going to do the ratio test because of that cancellation that works anytime you have something to the nth power. So I'm going to take absolute value, change everything to a plus 1. I have to be careful here. N plus 1 is all squared. The reciprocal of the original goes here. Take the limit, n goes to infinity, right? And I want it to be less than 1. All right, so tell me about some things. What cancels? All the x's except for 1. So I'll have absolute value x on top. Still got my limit. The 2's cancel, right? And then the other stuff doesn't quite cancel. Okay. I'm going to follow the same logic as before. I'm going to pull the absolute value x outside because this is the limit as n goes to infinity. So x can vary. It is a variable, but in terms of this limit, it's not. This limit only cares about n. Now the next part is up to you how you want to think about it. You can maybe already see it. I'm going to FOIL the denominator. And so when you do that, you can see n squared on top, n squared on bottom. Those are the highest degrees. Their leading coefficients are both 1. So the limit of what's left is 1. But don't forget that you're still multiplying by absolute value x. So the limit here is absolute value x. I didn't do an integral, right?
Yeah, you're right.
Any other questions? Yeah, Heidi?
So what would the radius of convergence be on this question?
That's a great question. So we're not done yet, right? But what we're trying to do is we're trying to figure out the radius and interval of convergence. Not integral. Radius and interval of convergence. So what does the ratio test want? So I remember yesterday during the quiz I wrote it over here, and I put the little shruggy guy if it's equal to 1. What's good? Less than 1. So when is this true? Well, for all you future math teachers in the room, all 3 of you, the one that's asleep. Now it's on tape. Absolute value less than 1 here means that you are, what does that mean? It means the distance from 0, or the magnitude of x, is less than 1. Those are on the, so make a little number line here. Here's 0, here's 1, here's minus 1. If your magnitude is less than 1, you're in here, right? So you're between minus 1 and 1, right? So that's my interval. But here's the tricky part. There are 4 intervals that satisfy this, right? Because the ratio test won't tell me about when it's equal to 1. So I have to check that. I don't know that if I should include, it could be open. One could be dark, or the other, or they could both be dark, right? Remember that from a long time ago? With number lines like that? So I don't know if I use brackets or if I use parentheses for the edges. So the way I'm going to check that is I'm going to just pick x to be those 2 things. So if x is 1, let's go back to the original series. That would make it 1 to the n is just 1. So I would get this series. Okay. So I plug in x for 1 in the original series, which is off the screen, but let me write it up here, over here. That's the original series. So when I plug in x equals 1, it's just 1 over 2n squared. Wait, does that series converge or diverge? Converge, right? It's basically a p-series. You can pull the 1/2 out, and then you know this is a convergent p-series. Okay, so that's convergent, which means that my interval, let's go back up here, my interval is minus 1 to 1, and I know that I'm got a closed bracket on that side, right? I just need to decide if the left side is open or closed. So when x is minus 1, I'd make x minus 1 in the sum, and I get minus 1 to the n. Does this converge or diverge? Convergence or divergence?
Oh, convergence.
Convergence, why, Chris?
The bottom, well, first of all, with the bottom will keep getting bigger and bigger.
Right, so alternating series test is as long as the terms go to 0 and it's alternating, it's good enough, it'll converge. Another option is to say the absolute value of this is the one above it, which converges, right? So that's the test for absolute convergence. If you take the absolute value and it still works, it'll definitely work. So however you want to think about it, so either AST or test for absolute convergence. In either case, it works, okay? That means that my interval is closed on both ends, okay? So these endpoints work. It still only works in a small little region from -1 to 1, where you will get a representation that works, but it does work. Now, one interesting thing about this one, let me go ahead and bring it up on Desmos. Here are these guys. So it's going to be sum, n goes from 1 to, we'll say c, and then x to the n, 2n squared. So we'll go by steps of 1. See, it's flipping back and forth just like before, so it's not going to actually land anywhere. It's going to blow up outside of -1 and 1. But you get a nice shape in the middle. But the issue with this one is I don't actually know what function this is modeling. It is a function in its own right, but I'm not clever enough to see like, oh, that was 1 over 1 plus x squared, or that was e to the x. But it's a function. So there are some functions that we're going to do that really we don't have a good expression for them other than series. And so this is still a function in its own right, and even when you sum it up, its domain, I guess, is -1 to 1 closed, right? Does that make sense?